Minerals are these beautiful solid materials produced by geologic processes that form rocks. Because chemical composition and arrangement of atoms will vary in different minerals, they will look different and have different names. And how can we identify minerals? It turns out that chemistry and internal arrangement of atoms not only affect how minerals look, but also how they break, feel, smell, and even taste. These physical properties can be used in tests to identify minerals. Today, we will talk about some of these properties: luster, hardness, color, streak, and breakage. Let's start with luster. Luster is given by the way light interacts with a mineral surface. Luster can be metallic or non-metallic. This is a great way to start our mineral identification. A mineral with metallic luster will look like an untarnished piece of metal, usually shiny and opaque. Examples are hematite, pyrite, or graphite. Minerals that don't shine like metals will be nonmetallic. These can be waxy like jade, earthy like kaolinite, silky like actinolite, glassy like many quartz specimens, or pearly like talc. Now let's talk about another mineral property: hardness. Hardness is a measure of how easily a mineral can scratch or be scratched by other materials. To test for that, we use a scale known as the Mohs hardness scale and materials that have a known hardness number. The Mohs scale is a relative scale. 10 common minerals are given numbers ranging from 1 to 10 based on their hardness. From hardest to softest, the minerals are diamond, corundum, topaz, quartz, orthoclase, apatite, fluorite, calcite, gypsum, and talc. The Mohs numbers of testing materials are given, so you can try to scratch the minerals with the materials to find which is harder. Some of the main testing materials are your fingernail, a penny, nails, a pocket knife, and a piece of window glass. For instance, this mineral is scratched by your fingernail. Because usually fingernails have a hardness number of 2.5, the mineral hardness should be lower. In fact, this is kaolinite, which has a hardness of 2 to 2.5. Another example: this mineral is scratched by a penny, which has a hardness of 3 to 3.5. Therefore, the mineral should have a hardness number lower than that. And it does. This is halite with a hardness number of 2 to 2.5. Finally, this is an example of a mineral that scratches window glass, so the mineral should have a hardness number higher than 5.5. Indeed, this is corundum, and it has a hardness number of 9. Corundum is in fact the second hardest mineral in the Mohs scale. The next property we'll talk about is color. Color is given by the interaction of the electromagnetic radiation of the visible region with the electrons of the atoms, molecules, and ions of the crystals. Minerals are colored because certain wavelengths of incident light are absorbed, and the color we perceive is produced by the remaining wavelengths that were not absorbed. Color is a reliable property for some minerals, usually with a metallic luster, but unreliable for many others, mostly with a non-metallic luster. Some minerals have such a wide range of colors that they were once thought to be different minerals. The same mineral may have different colors mostly because of minor chemical impurities and physical defects in the crystal structure. One example of a mineral that may have several colors is fluorite. Another example is quartz and its varieties, including amethyst, rose quartz, smoky quartz, milky quartz, and others. To evaluate the colors of minerals, sometimes we compare their color to some commonly known object or substance, like indigo blue, apple green, lemon yellow, and blood red, or to mineral color standards, such as vermilion red and emerald green. Some color standards for metals and alloys are used to describe the color of ore minerals, like tin white for arsenopyrite, steel gray for molybdenite, brass yellow for chalcopyrite, and copper red for native copper. Because sometimes the color of a mineral is unreliable for its identification, we use another mineral color-related property known as streak. The streak of a mineral is the color of its powder, which may differ from the mineral color. We get the powder by rubbing the minerals against an unglazed porcelain streak plate. The streak of a mineral will be generally similar for different specimens of a mineral, regardless of their color, and thus it's a reliable diagnostic property for many minerals. For instance, hematite may have different colors, including black, steel gray, silver, and reddish brown, but its streak will always be red to reddish brown. Another example is graphite. Graphite is silver-black with a metallic to dull luster. It gives a grayish-black streak. Pyrite has a metallic luster and a yellowish-gray to gray color, usually described as brass yellow, but its streak is black with a slightly green tinge. Pyrite is popularly known as fool's gold, since it's kind of similar to gold. One of the things that differentiate them is precisely the streak. The streak of gold is yellow and not greenish-black like pyrite. However, many minerals will not show a streak. Some of them will have a white or transparent streak, and if they are harder than the ceramic streak plate, we say they have no streak or a colorless streak. The next property that helps in mineral identification is breakage. Breakage refers to the resulting shape of a mineral after it breaks. The way a mineral breaks is controlled by whether there are zones of weak bonds in its structure or not. If there are no zones of particularly weak bonds, the minerals fracture. If there are one or more weak zones or surfaces, then cleavage occurs. Fracture may be either irregular or curved, which we refer to as conchoidal. Garnet is an example of a mineral that exhibits irregular fractures when it breaks. Quartz, on the other hand, shows a conchoidal fracture. Cleavage happens along one or more zones of weakness that exist in the crystal structure of minerals because some bonds holding atoms together are weaker in some directions than others. When describing cleavage, we note how many directions there are, and if there are more than one, we note the angles between them. For example, muscovite and biotite have one direction of cleavage. Potassium feldspar has two directions at 90 degrees. Amphiboles and pyroxenes each have two directions of cleavage and are similar in most other properties. But amphiboles cleave at 56 and 124 degrees, whereas pyroxenes cleave at nearly 90 degrees. The last examples are halite and calcite. They may look similar, but halite cleaves at three directions at 90 degrees, and calcite at three directions not at 90 degrees. So today we have discussed some of the tests we use to identify minerals based on some of their properties: luster, hardness, color, streak, and breakage. I hope you found that useful.